Hey guys, welcome to Conceptual Geometry, Worksession 3.11, Virtual Answer Key. Okay, the first question says ABCD is an isosceles trapezoid with bases AB and DC. We'll sketch that first. So just remember, in an isosceles trapezoid, you know that these legs are congruent, base angles are congruent, diagonals are congruent. Now we have to name this. It says bases A, B, and DC. So if you start up here with A, B has to go there because that would be a base C, D. It says AD is 4 times x minus 2, and BC is 6 times x minus 4. So obviously here, these two are equal. We are going to set these two expressions equal and solve that equation. Only difficulty here is that we need to use the distributive property. Let's distribute the 4 to both of those terms. That gives me 4x minus 8. And same thing here, we'll distribute the 6 to both of those. And that gives me 6x minus 24. Now let's get our x's on one side. I'll subtract 4x from both sides and add 24 to the other. Let's see, that gives me 16 equals 2x divided by 2, and x equals 8. What do the directions say? Find the length of AD. So now what I need to do is I need to take this value of 8, plug it in for the x right here. Okay, so AD is going to equal 4 times 8 minus 2. Well, that's 4 times 6. AD is 24. Okay, next one. This is probably the most challenging one on this whole work session. The lengths of the bases of an isosceles trapezoid are 10 and 16. If the length of each of the legs is 5, find the length of the altitude. So again, I need to sketch an isosceles trapezoid. So the two bases are the parallel sides. These are bases. One of them is 10, one of them is 16. So the shorter one will be 10. I'll put that up top. The longer one is 16. If the length of each of the legs is 5, find the length of the altitude. Well, remember, the altitude is right here. But you can place that anywhere you want. You can slide that wherever you want to slide that. So I'm going to put it over here. Sorry, let me move that. And that creates a right triangle. I'm trying to find this length here. I want to use Pythagorean theorem on this, but I don't know this side. So then what I'll also do is draw another altitude here, which creates a rectangle. Let me use green. And since this side is 10, the opposite side must also be 10. How do we find this length here? Well, we take 16 minus 10. That's 6. And then don't forget, we have to divide that by 2 because there's 2 pieces that will be the same length. So 6 divided by 2 is 3. So this length here is 3. So now in my right triangle, Pythagorean theorem, I'll have x squared plus 3 squared equals 5 squared. X squared plus 3 squared equals 5 squared. Let's subtract 3 squared from both sides. X squared equals, what's that, 2516, square root it. X is 4. Okay, easier one. ABCD is an isosceles trapezoid. AC is a diagonal. BD is the other diagonal. What do you know about the diagonals? They're equal. I'm not even going to label the diagram because it'll get a little bit cluttered. So I'm just going to set those two equal. 17x minus 3 equals 9x plus 45. Subtract 9x from both sides. Add 3 to both sides. That's 8x. 45, that's 48. Wow, big number. Divide by 8. X is 6. The question wants you to find the length of AC. All right, well, there's AC, so I'm going to plug that in. AC equals 17 times 6 minus 3. And I have no idea what that is. I have to plug that into the calculator. That actually gives me 99. Okay. Question 4 is multiple choice. It says, which statement about the diagonals of an isosceles trapezoid is always true? Well, that's pretty convenient. We just did a problem on an isosceles trapezoid diagonals. They're equal, okay? Do they bisect each other? Nope. That is not a midpoint. They are congruent. Yes, that is the correct answer, but I'm going to check the other ones just to make sure they are false. They are perpendicular to each other. No, they are not perpendicular. Those are not right angles, so it's not that. They divide the trapezoid into 4 congruent triangles. Clearly not. Look at these triangles here. 2 of them are, but not all 4, so no. Okay, moving on. Given isosceles trapezoid Kobe, if the measure of angle OKE is 2x plus 3, so there's enough room in there. Let me put that in the diagram. 2 times x plus 3. And the measure of angle BEK, so that's the other one, is 5 times x minus 6. Find x, measure of OKE, measure of angle KOB. I think it's pretty obvious here. It's an isosceles trapezoid, so these base angles are going to be equal. I take this, set it equal to that, and get x. Again, we'll have to use the distributive property. Let's distribute the 2. That gives me 2x plus 6. Distribute the 5. That gives me 5x minus 30. So I'll subtract, 2x from both sides. I'll add 30 to both sides. That gives me 36 here, 3x there. Divide by 3. 36 divided by 3 is 12. So x equals 12. Now, to find the measure of angle OKE, I need to plug 12 in there. Okay, I'll use a different color. So it'll be 2 times 12 plus 3. 12 plus 3 is 15. 2 times 15 is 30. So that equals 30 degrees. Now it also wants me to find the measure of angle KOB. Well, KOB is up here. It's not represented with an X. But remember, in a trapezoid, the same side interior angles are supplementary. So if this angle here is 30 degrees, to get that one, you take 180 minus 30. So that's going to be 150. Okay. Now, we're moving away from trapezoids. Now we are talking about a parallelogram. Find the value of x and y. Looks really complicated at first, but really I just want you to set up 2 different equations, right? What do we know in a parallelogram? Well, we know the opposite sides are equal. So this expression here equals that expression there. I'll use that to solve for x. 3x minus 7 equals 23 minus 2x. Well, in this case, I'll add 2x to both sides, and then I'll add the 7 to move it over. This will give me 5x equals 30. Divide by 5, and x equals 6. Okay, well, these opposite sides are also equal. So here's another equation. That will be 2y equals 9y minus 42. And there's a couple different ways you can solve this. I'm going to subtract 9y. I usually don't like dealing with negatives, but you'll see here the negatives will end up canceling out. 2y minus 9y is negative 7y equals negative 42, and we'll divide by that negative 7, and that's where the negatives will cancel. So y just equals 6. Okay, given rectangle bird with diagonal BR. Okay, so let's draw that. It doesn't matter where you start, just make sure you go around in a circle. BIRD, and then it says diagonal BR. So I'm only going to sketch in that one diagonal. BI is 12, let's label that side. BD is 5, okay. Find the length of BR. So I want to find that. Well, obviously, opposite sides are the same. It doesn't matter how you want to deal with this, but you can pick either triangle. I'll pick this one here. It's a right triangle. I'm going to use Pythagorean theorem. Opposite sides are the same, so I'll just bring my 12 over there and set this up. 5 squared plus 12 squared equals x squared. In the calculator, I'll add those two. That gives me 169 equals x squared. Then I take the square root, and x is 13. Okay, last one. In the accompanying diagram of rhombus dog. All right, it doesn't look like a rhombus, but they're stating it's a rhombus, so we know all four sides are the same. Measure of angle DGA. So let's trace that DGA. So I'm talking about this angle right here is 31 degrees. GA. All right, so might get a little cluttered here, but this whole diagonal is 12. I'm not going to put that in the diagram because remember we said when it comes to a rhombus, we like the pieces. So if the whole thing is 12, each piece is 6, and that's how I'm going to label it. So that length there is 6, and that length there is 6. DW is 16. So again, I know this whole length is 16, but I'm not going to label it as such. I'm going to label each piece 8 and 8. Okay, I'll try and color code that. So this will be 8 here, and that will be 8 there. Okay, so I need to find two things. The measure of angle GAW. GAW. So that's this angle here. Well, here's the nice thing about a rhombus. The diagonals bisect the angles. So where that 31 degrees is, I know these two angles are the same, and then the opposite angles are the same. So this angle over here is 31 degrees. So that's pretty easy. Don't have to do much math for that. Here's where it gets challenging. I need to find the perimeter of the rhombus. So that means I need to add all the sides. Well, what I'm going to do here, number one, you need to remember the diagonals are perpendicular in a rhombus, so it creates 4 right triangles. And I'm going to focus on one of the triangles. I don't care which one, but you just need to take one of them. And then I need to find the missing side. Call that x. So in this triangle here, trace it in blue, it's a right triangle. I know this length is 6, and I know that length is 8. So to set up the Pythagorean theorem, those are the legs. It'll be 6 squared plus 8 squared equals x squared. I'm going to throw this into the calculator. That gives me 100 equals x squared. Square root it. X is 10. So what does 10 represent? It represents the length of a side of that rhombus, and they're all going to be the same. So to find the perimeter, there's any number of ways you can do it. You can add 10 4 times. You can multiply by 4. It doesn't matter. But you should come up with 40 for that perimeter. Okay, guys, that concludes the virtual answer key for Worksession 3.11. I hope it helped. Please don't hesitate to reach out if you have any questions, and thanks for watching.